Okay, welcome back. Welcome back to Pykidz. We are continuing with composite types. We covered lists and then we covered tuples as well. So those both are done. Now we go into maps and dicts. That is maps. Maps is how multiple other languages call this data structure or composite type. Dicts is how Python calls it. So I will keep using dicts from now on. But if you hear the word map, you can sort of think that they are pretty much the same. If I use maps, don't get confused, they are the same dicts. And we'll get into what they are right now. Cool. So let's get started. Okay, maps are a collection, just like lists and just like tuples, but they are actually a collection of key and value, right? So let us say I want to, like a dictionary, right? So that's why dictionary is a fantastic name. Dictionary has a key, which is the word, and then the value, which is the description of that particular word. Now in Python dicts, you can have any key and value, and we will get into details of that soon. But the idea is that I can say pair two things. It's like a pair, right? So you can say this is the person and this is their favorite food. That's one way of using dicts. So let me take an example with our code. So I'm going to give this up. I am going to use ptpython. So now I am in my Python shell. So when I'm teaching these things, it's easier to use Python shell. Hopefully you are still, for learning you can also use Python shell, but if you want to write out big programs or reasonably big programs, then it's better to use the editor and save it as files. But when I'm trying to teach things, it's much easier, and when you want to try out things, it's much easier to use the Python shell, right? So I'm doing the same thing. You are probably using Python. That works too. So let us start. Beamsane. Okay, I'm back to Beamsane. Beamsane friends. I will just go with his brothers, and I'm going to shorten it. Yudhishthira is too long, so I'm going to Nakul, Arjun are reasonably small, and then Krishna is long, but it's okay. So this, what I'm typing now, is not a dict, it's a list, right? You know this. Now list allows you to just have items, but if I want to not just have items, I want to have their favorite foods. So that's where I am going to use a dict. So that works. So this is, use flowery brackets, right? Use this curly braces for representing a dictionary in Python. So that's the begin and end. Now I'll put the actual entries. So I said it's a pair, right? So you have a key. So key is the person, so beam, and the value. So again, this colon comes back. You saw colon in a different context. For a dict, for separating the key and value, you again use colon. So beam is the key and the value is his favorite food. Okay, we all know this, I think. If you have seen any of cartoon serials from India, you probably know this. So I'm going to use the same. Yudhi, actually I don't know what his favorite food is, so I'll put one of my favorite foods here, probably yours too. Ice cream, right? Oh, but small mistake here, I am using comma. Of course that doesn't work, right? I have to use Yudhi is the key, colon, that's a separator, and then the value, right? So now I put 2 entries, 3 more to go. Now Arjun, and okay, I'll just use Kulfi. Doesn't matter. I like Kulfi too. Hopefully you too. So 3 done. Saha, Sahadev, Saha, He's a nice guy, so we will put apple for him. And then we have Krishna. Krishna is, obviously everybody knows this, butter. When it goes to a new line, it Python does that, Python shell does that. And maybe I will just, so if I do, I'm done. So I have done the definition. Let us just look at Fair Foods. This is Fair Foods. If I look at the type of this, it's a dict. That's a dictionary or a map. So now you have a very basic idea, right? So let us look at formally defining them. So so that you know how this works, right? So let us say I have, so every dict is defined with these. This is an empty one. So this is actually a valid dict. So if I do a type of this, sorry, this, it's a dict, right? So a dict's typical definition is you put the key and then the value. This is how a dict is defined, right? I already showed you Fair Foods was also a dict, right? Now this is one way of defining, and this is called the literal definition, right? A way of doing it by literals, literally defining it. We have done this for lists too, and this is the way you do it for dictionaries. There is another way. There are actually many ways of defining dicts, more than one ways, like 2, 3 or 4, 5 ways. But I am just going to show you one more way, just for variety, right? I mean, you will see that. So that let's say I will define another map. I'm calling map. You can call it dict. So here I'm using the dict built-in function, which actually is sort of a constructor function. It allows you to construct dicts, right? So you can do this and then say key 1, that becomes the key itself. Comes like a, here you're actually passing a key as a parameter to the method. So key is a named parameter to a method, and we will cover this a little more detail later on. But in this format, let us finish this first. So here I'm using, this is a method call. So you are using, not using curly braces, you are using normal parentheses, brackets, right? So dict is a method call, again a built-in function call, and you are passing two different values. Now if I look at this another map now, see, you can see it has become the key one, which was the sort of the parameter name, has become the key itself. And therefore this kind of this method, you have to ensure that the key has to be a string, obviously. I mean, because it has to follow a naming convention of a variable, so you have to, or a parameter name, so you have to follow that. So here this is one way of doing it. I can do it, if I try to do this, if I try to do something like this, you might think, oh, why not I just put some other quote here, right? This won't work. See, it is not allowing me to do that. So it looks like, sorry, if I change this to, it's still not allowing me. Only way to get this to work is actually take out the quote, because it has to follow the, what I'm making a mistake here. Okay. Oh, okay. In this case, I have to use equal to, because this is like a method passing, right? So if I do this, this will work. Now if you look at another map, this works. So you can't put quotes in this form of trying to define dictionaries or dicts. I prefer the literal notation, the first one which I used for favorite foods, right? This is the notation I prefer, and I have not seen many people using this this dict thing. I mean, you might use it, but I have not seen it much use. Okay, we have defined them obviously. Now let us try to see the next thing obviously is access, right? So let us quickly try to do that. So if I have to access, I'll just clear this off. So access, the great thing about a dictionary is that it's a key and value, right? So you can get to the value using the key to get to the value. That is the primary use of this data structure. It allows, you might have lots of items, right? If I want to find out, okay, what is a favorite food? So let us say I have favorite foods of hundreds of your friends, right? And I want to find out which is the favorite food of among the 100 people of Beam. I can just use the key to get hold of it. So I'll show you. So what happens is, if D is a dictionary or a dict, then the way you do it is just, you remember the square brackets, like the indexing stuff which we saw in list. It's very similar, but now here you have to pass the key instead of the index. So I am going to do it for fav foods, right? We already have this, and we know fav foods contains Udhi's favorite food. So let us go, and if you remember it, right, it is ice cream, and I'm just going to show you all of them to see if it's correct. Yeah, Udhi is looking at his favorite food is ice cream. So you are now able to access the value using the key, right? That is the key thing about a dictionary. Now if I actually access some other, let us say for Duryodhana, Duri is not there in this list of favorite foods, but let's I try to do that, you get a key error. So this is an exception, and exceptions are, you have seen these errors coming earlier. You in the classes you have seen errors, we have seen these errors, right? They are different kinds of errors. For a dictionary, whenever you try to access a value with a key which is not there in the dictionary, then it will throw this error. Python will throw this error. It's saying that key error, this key does not exist, so I'm giving you a key error. When you play with dictionary, when you see this error, you have to understand, oh okay, if this is the case, then that means this particular key is not there in the dictionary, so I can't get a value out of it, right? That is what it means. So keep this in mind. Now you will, if you try to do this, let's say, because you are habitual from your list of days, it will not work, because it again thinks 0 is a key. 0 is not a key, because you look at the current set of entries, there's Beam, Udhi, but there's no 0, right? So it doesn't work. Make sense? Now what can be a key in a dictionary? That's what we will look at next. So a key in a dictionary can be any immutable type, right? And again, we have been talking about immutable a lot, and I'm going to now use some example to show you this immutable, what are these immutable data types. So we'll use some existing data which you already know and try to look at what immutability means. Now I am talking about v equal to, let's say I'm taking a string. Now v is a variable, right? And I showed you this id method, right? Now this let me just show you, help id. It returns an identity of an object, and it's guaranteed to be unique among existing objects in the current Python memory, right? So that's what this means. So now I'm going to do id of v. Now this is a unique identifier for this string, right? This is a string. This is a unique identifier for that. Now let us say I'm going to have, we had v equal to abc, I'm going to do a is equal to abc. Now let us look at id of a. You see, this is actually the same value. So this is an identifier of the actual string, right? It's not an identifier for the variable. Remember, every time I've told you this before, the data type is for the actual data, not the variable. Similarly, the address is for the actual data and not the variable, right? So v is a different variable, a is a different variable, but since they point to the same string, they have the same ID, right? So keep this in mind, and v and a are just aliases to the same object. It's called aliasing, right? Now I'm going to do some trick. So we know what v is, we know what a is. Now I'm going to do v equal to, I can do this, right? V plus a is nothing but you're concatenating, right? You're taking ABC and ABC and you are merging them, right? And I am taking v and a and merging them and actually assigning it to v itself, okay? Now when I do this, now when you look at v, it says ABC, ABC, that we know. But now we look at ID of v, it is different. This was 452, 492, that was a, and similarly that was the same for v also, but now v has changed. It has become 45673, whatever, right? So this means makes sense, right? Now it is pointing to a totally different string. It is not pointing to ABC, it's actually pointing to ABC, ABC, which is a different string from ABC. So the address or the memory identifier is different. If I look at a again, a is still, because a has not changed, I have assigned it to v, not a. So a is still the same, and if I try to look at a's ID, it is 4524, the same old. If you see this, yeah, this is a, it remains the same, right? It has not changed. So what this essentially tells you is that strings are immutable. If you try to change them, they will just create a different object with a different identifier. I took ABC and ABC and added another ABC to it. It will not go and change that particular object. It actually created a totally different object with a different identifier. So this happens for all immutable objects. That is strings, integers, all these are value objects. These are immutable. They don't change. They just create a new object. When you try to do operations, they create a new object, right? So, and coming back to our dict, dict can have any key which is immutable, which means it can have strings, it can have integers. Tell me one more it can have. It can even have tuples, right? Tuples we said are immutable. So it can have any of these things as keys. So that is the grammatical definition of a key. It has to be immutable. As long as it is immutable, Python will allow you to have it as a key. So let us actually try to play with dict and see how things work. So let us have some fun here. Let us try to, we know lists and we know dicts now. So let us try to see if I can make them similar. I said dicts can have integer as their key because integers are immutable, right? Let us first define a list. We all know this. So let's say I have a list of articles, and I'm going to put the articles. This is the English articles, right? So okay, and the. So this is a list. Now I'm going to create a list like articles dict. I'm just using this name so that it's clear for you. And I said, and dicts are always defined by curly braces, right? So now I'm going to make a key as an integer 0, right? And then separated by key separated by colon and then the value a. Now, and then I'm going to say 1 and I'm going to say and then I'm going to say 2 and I'm going to say the. Done? Both are here. Now if I do list of articles and if I do 0, obviously that works. But the cool thing is, if I try to use this and then I do this again, that also works, right? If I try to do 2, works. If I try to do this, that also works. But let us try to stretch this more, right? Now this, when I do, it says index out of range. We have seen this before, right? We have tried to use play with lists, and when you step outside the range of indexes 0, 1, 2, because there are 3 entries, it will say index out of range. And see, this is an index error. And when I try to do the same thing with this guy, this dict, what do you expect it will say? Key error, right? There is no such key as 3. There is not an index, it's actually a set of keys. So though it made it initially look like they are looking the same, but they actually are underneath completely different. One works with the concept of indexes, 0, 1, 2 indexes, but dicts work with the concept of keys, and keys can be anything, right? Indexes are always 0, 1, 2 and they just go that way, but in dicts, in dictionaries, you can put anything as key, right? We have seen this already. If a list will allow you to do negative indexing, right? I can do this and this will give me the. Try the same thing with this guy, key error, right? It doesn't work. So lists, in the context of dictionaries, keys can be any immutable type, including like integer, string, it can be functions, it can be even tuples. I said this, right? But a key cannot be another dict, because dict itself is changeable. You can change values, and it cannot be a list because list is also changeable, right? So when you have these two things, you cannot put them into a. So let us say, I'll show you that. Say I have parts of speech, and I am going to say, try to do this. I have already got list of articles. So this is a list, right? I'm going to make this the key, and I'm going to say the value is this string. I mean, when I probably you'll never use it like this, but I'm trying to demonstrate how this works. See, it says unhashable type, which means if it is changeable, it is not hashable. It can't, therefore, you can't use it as a key, right? It has to be immutable so that it can hash to the same value. So if you change internally, it can't be hashed to the same value. So we will not get into what hashing is, but just understand that because a list is mutable, it is not immutable. Therefore, a dict cannot have it as a key. The key always has to be something which cannot be changed. Make sense? Cool. If I go the other way, now if I, instead of this, let us say I am going to, remember I said you can even have a, if I create a tuple, let us say, of, and this is another way of defining a tuple. I can actually take a list and give it to this list of articles. So tuple is another built-in function, and if I pass a list to it, actually you can pass something called iterables, but a list to it, it will convert it into a tuple. Now if you do this and then I say tup, this is fine. And now if I put parts of speech as tup and 2 articles, this will work because tuples are mutable, right? Works. We talked a lot about keys because it's a very key concept in dictionaries, right? So let us now look at quickly at how you can change a dictionary, right? So let us go back and look at favorite foods, right? So we have favorite foods. Now let us say I want to make Saha a little more naughty, right? So he used to like apple, but he likes actually apple pie. So I'm going to use one of the methods which dict offers, and we'll cover this method and a few more methods later on. But if I see here, this is, it completes, and then I am going to update, and here I am actually going to give another dict. That's how this particular method works. It will Saha, right? This is one way of updating a dict. There are other ways too, but we will use this now because my intention is not to tell you what are the different methods, but my intention is to teach you about the data structure, what you can do with it, right? You can always look up these methods by looking at documentation. Now, if I do this, so I'm updating the dictionary. Now, let us see what happened to Foods. If you see, it started off with this previous line, Saha had apple. Now, Saha got updated to apple pie, right? So, the update happens here, and remember, it will pick the correct key, the corresponding key, and update its value. And the good thing about a dict is values can be anything. It can be a list, it can be it can be mutable, immutable, whatever, it doesn't matter. Dictionaries will not stop you from having any kind of value. You can have the same thing repeated again and again, whatever you want, it doesn't matter. The keys are immutable, but the values can be anything. So the key is one thing, one way, has a set of rules around it. Values can be anything. So actually, if I look at my parts of speech earlier, I can actually, so I can do a parts of speech this way. So I can say articles. Now articles is a string and therefore immutable, right? So I can have this, and then I can put a list of articles. This is perfectly fine. So I have now a list in the dictionary, but as a value. So that works. Now we looked at an update method to update. That seems a bit laborious and little more cumbersome, right? So obviously we want an easier way. Now how did we update things in a list? We would generally do something like, okay, I have a list of articles, and then I could just pick a particular index, say, and then update it with the value, right? This is what you used to do. Whatever value you put here, it will get updated. This is what we used to do. Very similar thing can be done with a dictionary too, but obviously we have to do slight changes. So now I can, let us look at Foods. Now if I can actually do Foods. Now in list, the way you get to a particular value is through the index, right? Here is through the key. So we say Saha, which is a key, I am putting him back to apple. Now if I go back and see Foods, got updated, right? So you don't have to do this update method with a dict, but update method has its own advantage, and we will look at that maybe later on. But this is another simple way of doing it. Now what you can also do is you can use the same method to actually add a new value into the dictionary, right? What I'm going to do is, we talked about all these fellows, and Draupadi is also a friend of Beam, so we add Draupadi, and maybe she likes Kheer, right? If I do this, and now if I look at Foods, you see there is a totally new entry. So Beam, Yudhi, Arjun, Saha, Krishna, and now Draupadi too. She has also come into this list. Can you see that? I'm actually stretching it a bit so that you can see it more clearly, right? So the same assignment technique can be used to even add values to a map or a dict. This cannot be done in the case of a list, right? You try to add a new thing at the end, it will, unless you use the append method, if you use this kind of assignment, it will say index out of bound. But here you can do that. So that's one cool thing. Now we have seen update, we have seen create addition, we can also do deletion, we can remove something. So let us say I want to, let us say, remove Krishna from this list. So again, we can use the del keyword. This is not a built-in function, it's a keyword, right? And then I have to say this particular dict name, dict, that variable, and I have to put the key. Key is everything in a dict. If you don't know the key, have the keys of a dict, you can't do anything with it, right? So here I am trying to remove Krishna, so I'm going to say this, and when this is done, and let us look at favorites. Krishna is gone, right? So that is how you can delete an item from the list, sorry, from the dict. Okay. And one thing is that if you try to look for operators like plus and all for a dict, that's not present. So if I try to do, say, if I want to add Krishna back, and if I say favorites plus Krishna and butter, this is not there, right? This operand does not exist, right? But what I can do now is, if you remember the update method, if you look at now favorites, Krishna is back, right? So update can be used. Now update can be used to add. The great thing about update is that I can do this too. Let us say I want to do Krishna butter, nothing has changed, so we will leave it as is. But I want to, I'm going to make this Krishna butter milk. So this is going to, and then I'm saying Yudi is Rasagulla, and let us say I want to add Duri here, and I'm going to say Papadi chart. Maybe if I do this, and if I look at foods, see, Yudi was earlier ice cream, it has become Rasgulla, so it has done an update, and then it changed Krishna to buttermilk instead of butter, and it also inserted Duri with Papadi chaat. So it took this entire dict which you are passing and merged it into the existing dict, right? So wherever the keys match, it went and updated it. Where there's a new key, it just added it. So this is why update is useful, right? And I have to just work with one key at a time, then you just use assignment, right? The way I did earlier. But when I'm trying to look at, try to manipulate multiple dictionaries, just many keys, and try to merge them, update comes in very handy, right? Make sense? Cool. So we looked at changing the dict. Now let us move on and do the last piece, which is the usual membership and methods and maybe the truthy stuff, right? So I think I will cover those things and then we should be done. So we clear this out. So let us say I want to find out, and in the case of dictionaries, everything is bound to the key, right? So if you look at the membership in and not in, which is we saw in the case of tuples and lists, they worked on the values because there is no concept of keys in those. But in the case of a dictionary, the same in and not in works with the keys. The values are just incidental, they are there, you want to get those values, but keys are important in dictionaries, right? So the in and not in is working at that level. So if I do this, Arjun is in Fair Foods. It's true because Fair Foods has Arjun, right? You see Arjun here, so it's there. Now if I do say Krishna, now Krishna is there here. Let us say I go delete Krishna. Del Fair Foods, you saw this already. I'm just going to, so if I now look at Fair Foods, Krishna is no longer there, and now if I try to do Krishna in Fair Foods, what do you think will happen? No, it's not there. And if you try to say we saw Arjun is there, and maybe to try to use a value, it won't be, it will not do, right? Kulfi is the favorite food of Arjun in our list, in our dict. But if I try to do that, it's still going to say false because it's only checking against the keys and not the values. So always looks at keys and not values. Dictionaries looks for keys. Let's now look at a couple more methods, right? So we looked at update already. So I'm now going to show, and we were seeing the way to access these entries, right? So we can say Duri is there now. Oh, I missed something here. I missed the code. So property chart. Now, but if I do the same thing with Krishna, I remove Krishna, so it will give a key error. Now there is a cool method called get. Now I am going to say faithfuls.get, and then I say Krishna. So let us start with Duri, and I say since I give some no idea, let's say. So because Duri had the value, had a value for this key, so this Duri key exists, so property chart came. So if I try the same thing with Krishna, normally we would get a key error, but when I use the get method, we get the no idea, which means what is happening is when you use a get method, if it does not find the key, right, in the given dictionary, it will use the value you pass next as parameter. So two parameters are passed. First is the key, and the next one is the, so let me show you this. Start get, let us see if this works. So see here, so the get method takes the first parameter as key and the second method as a default value, right? This allows, so when you have the key is there in the dictionary, it will return a value or it will return the default value, because we provided no idea, so it gave back Krishna is not there, so it returned the default value which you already provided no idea. So this is very useful, so that in your program, when you are trying to, you don't know what keys exist in the given dict and you don't want to get the error, you can use some kind of a filler value saying that let me go and get this, try to access and get the value of this key, and if I don't find it, I'll get my default value and I can check, oh, if this is the default value, which means this key does not exist. Otherwise, what happens if I use a direct way of accessing, you will get an error and you don't handle error, right? So get is that way easier to use. So get is a very useful method, and I have myself used get a lot. There are other methods, d.items. If I do this, d in this case foods, d is a dictionary, and if I do items, so it's completing, and always put the braces. If you don't put that, it will just give you, if I do this, it just says there's a little method like this. If you do this, then only the method gets executed. See, it tells me, it gives you a list of tuples with the key and value, right? See, this is a list. Items gives you a list, the square brackets tells you, and then there are tuples inside it. Each tuple contains a key and a value. This is what items will give you. Sometimes this can be handy if I want to do something with the contents of it. Other cases, so I can actually say something like, because it's a list, I can do 2. So this does not work because it is not really, it looks like a list, but it's not really a list, right? It's because the underlying object is called a dict items. It's not a list, right? If I want to do this, then I have to, so when you saw this square brackets, you thought it's a list. It's not a list, it's an underlying object called dict items. Now, if I really want to do what I just did, then I have to do this items, and then I have to use the constructor method called list, which means this will take that dict items and convert into a list, right? And then I can do this. Now I got beam tuple, I can do 2 and I got this also, Arjun Kulfi. So if you look at this type of this, that's a tuple, but the outside one is not a list. It looks like a list and it will work as a list in some cases, but as you try to just do an indexing, it does not work. You have to actually give that item to a list constructor function, a built-in function, and then you will get back a list which you can then use indexing on. Cool. So we covered update earlier, we covered get, we covered items. Now we will cover the last one which I wanted to. This is Fair Foods. I'm going to do dot clear. What do you think it will do? You want to find out? Go do help and then do this. It will remove all items from the dictionary. So I'm going to actually now show you that. Now if I try to look at Fair Foods, it's empty. Everything is gone, right? Now last item on the list, on our list of topics for a dictionary, we have to look at falsy, right? So what do you think is falsy in a dict? I think you would have guessed it by now. This is falsy, right? If you look at Fair Foods, which was there earlier, it is now empty, so it will also be falsy. But if I look at the list of, I take a list of, this guy has some value, so if I try to do a bool for finding out it's true, it is true because it has got some keys and values. An empty dict is considered falsy. Otherwise, if you find something, I can even put some value into our favorite fruits, right? So if I can do this, this will add a new value. So Padi equal to here. If you do this, Fair Foods now has a value, now has a key and a value, and therefore if I try to do a boolean of this now, it will become true because now we have added an item in it, a key and a value pair, right? So that's it. I think we covered maps or dicts in pretty detail. We looked at how to define them, how to access them, what is the importance of a key, and use the key is everything in a dict, right? So you looked at how keys can be defined, what are the rules around it, and then we looked at how you can manipulate dictionaries, like how can you add new entries, how can you update entries, how you can remove entries. We also looked at a few methods which will allow you to manipulate dicts and also dicts or dictionaries, and we also looked at the nature of membership, right? How membership again works in keys, and then we also looked at falsy and truthy. That's all for this video. I think we have done 3 of the composite types. There's only one remaining, which is a sets, which we will cover in the next session. As usual, try these things out. Do actually, if you look at these videos and try it on the terminal along with watching the videos, you will learn it better. You will, and when you try these, you will make mistakes, and those mistakes will allow you to learn this better. So try out, do. That's how you will learn. Any questions, any doubts, use the comments in YouTube and ask them. I will surely try and answer them. Thank you. Catch you on the next one.